All right. So now we are going to see how to connect our Flask server to our Postgres database. We're going to use two different Python libraries called SQL Alchemy and PsychoPG. Along the way, we're actually going to create something called a model that does some of the work of SQL for us. It's sort of in between a class and a table. And then we're going to see how to modify our Flask server to get data from the database and send it back to the client. And just to kind of recap here, let me just make a nice big diagram of my computer. And like we were talking about, my computer has its own little network. And these same principles apply if we have multiple computers on a network, right? And we know that we have different things running on different ports. We know that we have the Postgres database engine, right? And that's running on port 5432. And then inside Postgres, as we learned recently, we can put all sorts of data. And just to recap and review some of that, I've got another shell session open up here, and I've got an SQL file that we were using to create a students table, right? And we create a students table that has an ID that's a primary key that's auto incrementing first name and last name. And each of these say what kind of value is allowed in this column, an age and a grade. And I have some CSV data here. And we're going to copy that CSV data and import it into Postgres and into the students table. And to confirm everything works, we're going to run a select query to display our student data. I'm going to use pSQL to connect to Postgres. And now I'm logged into Postgres, but I want to make a database for my project, for my Flask API to talk to, and let's name this database school. And now let's connect to this database using the pSQL / command C. And now I'm connected to the school database. And using the pSQL / D command, we see we don't have any tables or anything yet. So now I'm going to use this /I command on pSQL and give it the relative path to my SQL file. And we're going to run all this SQL, right? And so remember, this is just text and this is a bunch of commands. SQL is its own little programming language. And so when I'm running this, it's going to talk to Postgres that's running on my computer and create a table and load the data into the database. And somewhere on my computer, Postgres is probably saving that data in a file, but we don't need to care because the beauty of a database engine is it abstracts the file system away. I don't have to worry about how Postgres stores the data on my computer because that's Postgres's job. That's like its one job is to make sure the data is stored safely, that it's not modified incorrectly or messed with, or nothing fails. And so that's the beauty of using a database. And so now I can go ahead and run this. And in fact, if I do select star from students to look at all the students, we see we have all of our students there. If I just wanted to see their first name, I would do this, and maybe let's just say where ID equals 2, right? And we can see Jane's information and /D or /D gives me information about a table. And so in our Postgres database, we now have that school DB right? We might have multiple databases, but right, for our purposes, we're only worrying about one. And in here, we have a students table. And as we were just learning, next up, we have Flask. And let's make Flask red. And Flask is running on whatever port I tell it to. By convention, we usually use port 8000 for stuff like this. So this is my Flask server. And this is only running when I run the Flask server. So I have to actually start my server by running my API PY program. Right, and now the Flask server is running on port 8000. And from here, I have a lot of different ways to talk to my Flask server. One is with my browser, with Chrome. Right, which is also running on my computer. And I can have my browser talk to Flask. And we'll use the other kind of arrow because that one doesn't seem to want to play nice. Right, and the way that things talk over a network is with HTTP requests for our intents and purposes. And we want to get all of our students. And let's make this a bit smaller. And then the Flask server sends that information back. Right, and I'm just going to make this very simple. I'm not going to write out all the information, but you know, we have some sort of JSON array of objects that it sends back. But the browser is not the only program on my computer that I can use to talk to the Flask server. We've also seen that I can use the curl command line program. Right, if I have another shell session here and I do curl HTTP localhost port 8000 / API / v1 / students. And let's change this to be correct. And we'll change this to be correct too. Right, and it's again like sending a letter to a specific apartment in an apartment building. And if my Flask server isn't running, when I try to use curl to do that, we're out of luck. We see failed to connect. There's nothing running on that port. And then we also saw that I could write another program whose job is to talk to the server. And let's make this a little smaller so there's enough room. There we go. And we saw this with client.js, where I can actually write some JavaScript code that's going to use JavaScript to send an HTTP request to talk to my server to get data. And so I just want to pause and check in here and see if folks have questions, and also if this review and sort of going over how really now we have a system, right? These different parts talk to each other over my computer's local network is useful. And the beauty of this is because of the way that IP addresses and ports and networking works is if instead of all of these things running on one computer, I had some of these running on one computer and some of these running on other computers over a network, whether it's, say, my school's local network or a business network or the entire internet, aka the cloud, it all works the exact same way. Alex, yes, sir.
So can this get real matrix-like, real nested? because if you create another website utilizing the Poke API and someone uses an API from your website, does it just layer?
It absolutely can, yes.
Okay.
Yeah, and we'll sort of see that in action later. We're not going to see that now, but later we will learn later how to have my server talk to someone else's API, like the Poke API. The same way where I could send you a letter to the apartment that you live, like 2245 West Broadway, apartment 3. And then you could send a letter to someone in a different apartment building in a different apartment, and they could write you back something, and you could send me back what they wrote to you. We can do the same thing.
That makes sense. Okay. And just for clarity's sake on my end, port 8000, your Flask server, is in this case the REST API?
Correct.
Nice. Okay, got it.
Yeah. You'll A REST API is a certain kind of server. You'll hear the two terms kind of used interchangeably a lot. What we are really learning to build is REST APIs, because for a lot of modern web apps, what ends up happening is all the HTML actually gets created inside the browser with JavaScript and React.js, though we have not learned about this yet. And so then the server's only job really is to get data from the database and send it back. And this is what a REST API is, really. And the advantage of this is flexibility, right? The same way with the Poke API, I can do whatever I want with this data once I get it. With a REST API, I could write a JavaScript program to do something with that Pokemon data. I could write a command line program to do something with it. Or I could write a program to run in the browser to get that Pokemon data and maybe use it for a Pokemon game that runs in the browser. And so what we're going to look at now is, how do I get that Pokemon data, or in our example, the student data, instead of having it live over here as like Python code, as a list. And let me pull up our Python code so we can look at it. Right? We have students as a Python list. I don't want to be using this data. I want to be using this data. So now let's see how we get Flask and Postgres to talk to each other. Because my goal here at the end of the day is going to be, I have my endpoint here to return all the students. And we'll see how to do this in just a little bit. So first, let's see how we get Flask to connect to Postgres. And to do this, we have to use two libraries. One is called PsychoPG. And as it says here, it's a database adapter for Python. So this is a Python library that's been written specifically to talk to Postgres, right? And there's a whole bunch of standards and specifications around this. And it's actually mostly written in C. And then there's some sort of Python sort of wrapping around it. But this is what actually talks to Postgres from Python. And the good news is this is pretty straightforward to install. I need to make sure I have my virtual environment activated, and then I can run pip install, and let me give us a little more real estate here. Now, I actually need to go to PsychoPG3 because there is a newer version. PsychoPG2 is the old version, and they actually have some really beautiful diagrams here that sort of, they have a nice handshake here, right, between the database, which is always represented as a cylinder, and our server or program. And we're going to install PsychoPG3. And for some reason, they've kind of changed the naming convention. And this is all written down in the curriculum as well. So, and I almost definitely misspelled this, so let's try this again.
Documentation has it in quotes.
Yeah.
Oh, thank you. Yeah, with binary in double quotes or single quotes.
No, the whole Psycho PG thing,
Oh,
all the
thank
way
you.
to binary. Yeah.
Yep. I apologize. It's always something like that that gets you. And of course, you'd think they'd have it here, but they don't. And there we go. And now it's installed. And in fact, I already had it installed, so it says requirement already installed. When you all run this later, it will you'll see an install message. And let's go ahead and we'll just drop this in the README. But again, we have this in the curriculum. And we're going to do a little bit of setup here. We don't need to do a lot of setup with PsychoPG, but we do with the next library that we need to install, which is called SQL Alchemy. And this one uses PsychoPG under the hood. So SQL Alchemy is what we're going to use to do most of the work. There's this term we'll learn more about, object relationship mapper, object relational mapper. And in essence, what this will let us do is we can use some of the Python OOP styles we know and love, like having a student class, and kind of connect it to our database tables, right? So I can have a student class over here, or a student table, excuse me, and we'll make this singular just for consistency. But then I can also have, and we'll make this, let's make it a rhomboid. I can have a student model. And SQL Alchemy and PsychoPG will make it so these things talk to each other. So I actually will not be writing like SQL code directly. I'll be transforming this student class into an SQL Alchemy model and then using that to talk to the database. So that's where we're heading towards. That's where we're going to end up. But to do this, we have to go ahead and we have to install SQL Alchemy. There is an installation guide. However, we kind of want to install it specifically for Flask. There is a quick start and a comprehensive tutorial. If you want to dig into this, it's worth maybe digging into it a little bit. However, later in the course, when we learn about Django, Django has its own different ORM called Django models, and we'll be using that a lot. So I think digging into this a little bit is good, but we don't have to go too deep. And often, because these things are so common and so powerful, someone has already made another Python library specifically for using SQL Alchemy with Flask that does a lot of the sort of grunt work of setting stuff up and configuring things and making everything look nice. And this is actually what we're going to install and use. So I'm going to run pip install, and I think we can skip the -u. Flask SQL Alchemy. I already have it installed. Later on, when you all run this, it will say a bunch of installation steps. And then we can go ahead and import it. And we don't need to do quite all the same work that this does here. So I'll kind of guide us through the next part, but this can get us started. And here we're going to import this SQL alchemy class. And now we're going to use this to make this connection between Postgres and our database real. And to do this, we have to do a little bit of configuration. And in fact, to go back to the Flask GitHub page that we looked at a little bit earlier, and to look at the Flask class. And to look at, if we scroll down far enough, this configuration object. What we're going to be doing is adding some database configuration information here, basically, for SQL Alchemy. So let's put this print statement up here. And now we're going to configure Flask to talk to our database. And it's a lot less work than it seems, but the thing about configuration stuff is there's a lot of information packed into like one line of code. So we're going to interact with basically this config dictionary on the Flask app that we've created, the instance of Flask. And we're going to give it a URI, which is very similar to a URL, that's going to point to our database. And so we need to tell it that it's talking to Postgres. We need to tell it that it's going to use psychopg to talk to Postgres. I need to give it my Postgres username. Right? And if we go back into pSQL, let's see. I forget off the top of my head how to list my username, but your username is going to be the same as your Linux username. So for me, it's Adam C. And then I need to give it the host name. I don't need to give it the port, I don't believe, for localhost. And then after the slash, the name of the database, which in this case is school. And now that I've done this, I'm going to create an instance of SQL Alchemy that I can then use to talk to the database. And so this is taking this Flask app and it's going to grab all this configuration information and give us an instance of this SQL Alchemy class that we can use to talk to our database. Yeah, and for some reason I have that no definition issue come up. And if we look through here, we can take a quick look at the SQL Alchemy class as well. Though this might be a bit harder to navigate through. So I may not dig through this one too much because I think it'll be harder for us to find what we want. But we see here they have different kinds of connectors and there's a whole bunch of stuff happening under the hood. But the end state is we get this DB class that can do all sorts of different stuff. And I do want to go ahead and I want to run my code to make sure I don't have a typo or haven't done anything wrong. Or that this didn't break. I'm not expecting it to do anything. I just want to make sure nothing is broken. And indeed, I do have an error. It looks like there's a step that we missed along the way. So if we look at this error message, we see down here, it says runtime error. Either SQL Alchemy database URI or SQL Alchemy binds must be set. You almost always want to look at the top or the bottom of an error message. So this makes me wonder if I just have a typo, because I do have this set over here.
You're missing the A in database.
Ah, thank you so much. The best kind of problem to have. Right? And so, and in fact, a great way to check for something like that would be to copy this and then use VS Code's find. Because when you're debugging stuff like that, you want to avoid typing in sort of instances of introducing more programmer error. And now we see our Flask app is running. We're not doing anything with the database yet, but the connection ran and it didn't break, which is awesome. So now we have to take this student class and we have to turn it into an SQL Alchemy model. So a model is a class that represents a database table. Right? And to go back to our diagram, we have this student table here. And I need to have a student model. And then I'm going to use that in my Python code to talk to Postgres. So I'm not actually going to write SQL. And I've already made the student table in the database. You can actually use the model to create the table. But it's okay to do it this way as well. And we want to make sure that our model is organized the same way, right? That we have the same values here for first name, last name, age, grade, and the ID. So the first thing we need to do is this needs to inherit from SQL Alchemy's model class. And this is what's going to give us all of our behavior. And I'm not sure if the SQL Alchemy docs will really be useful here. They might be a little too comprehensive. I think it goes into a little too much detail here to be useful. So I'm not going to worry about it too much. But we're having student inherit from the SQL Alchemy model. And when we do this, we actually don't want this dunder init method anymore. Models don't take in arguments in dunder init. Instead, models use class attributes. And so when I'm building a model, it's going to look like this. And we're really using like the SQL Alchemy model class a lot. And let's see if we can't find the column types, because that would be nice to see in the docs. Here we go. So this is where documentation can get more challenging to read through as this is extremely dense. But we can see kind of what's going on here is SQL Alchemy has just tons of different classes inheriting from other classes. And so when I want to create a model that has different fields that have different types, I'm using all of these different classes. The SQL Alchemy documentation is pretty dense, so I'm not sure how much it's worth digging through it. I don't want to get too lost in the sauce, but I think what is useful is we can pull up side by side our SQL code and our Python code as we build this out. And I think we'll be able to sort of see the correspondences. And you guys will be able to see the pattern pretty quickly. I see there's a couple questions. Give me just a minute. I'd like to finish building this step out and then I'll pause for questions. And so each column in a table now becomes a field or a class attribute on my model. And I use this syntax here of DB and column, and then I give it a type, and then I can give it different arguments. And this is how you build a model with SQL Alchemy. And I am going to write a dunder repr method so we can print this out as a string when we want, and it's going to print out something really simple, which is just going to be the ID and the first name of the student. And yes, let's pause for questions. Tom, yes, sir.
So slightly multi-part, just to confirm, db.column, we use column because that's what we inherited with db.model, right?
Yeah, that's a great question. There's a lot going on with this DB class instance. It's doing a lot of different things. There is a model class in SQL Alchemy that we're inheriting here. And then, like you're saying, once this is inheriting from this, it enables us to do these other things. But then what we do here is DB also has a column class. So we're basically creating like an instance of a column and assigning it here to ID. And this is actually a class attribute of student. But the way to think about each of these is like as a field that maps to the column of an SQL table. Because you can see there's so much stuff on this DB class here, right? We have column, we have integer, and so on. So it's kind of like a Swiss Army knife. You know, the Swiss Army knife has a corkscrew, it has a tiny scissors, it has the big knife, it has the nail file. They're all on the Swiss Army knife, but you don't have to like use the corkscrew before you use the nail file. But obviously, like these things have indeed been designed to use together. And if I wasn't inheriting from the model class, then all this would probably break. Does that help answer your question?
Yeah, it does. And since they don't utilize the init method, it's because of the inheritances is basically telling it that it's it's basically the stand-in for the init, right? Like this is going to happen every instance or model.
Yeah,
Okay.
yeah. If we could look at the Python source code for this model class here, which I apologize that I wasn't able to find, it would have its own init method that is probably getting called. Or it might not be because it's using these class attributes. Um, the truth is we don't have to worry about it. Because in essence, we're not writing our own class from scratch. We're really writing a class in this special way so we can use it as an SQL Alchemy model. And we'll see this more and more as we start working with frameworks like Django. And sometimes the docs are really good. Sometimes with SQL Alchemy, they're a bit dense, but this is a big difference, right? Where like I kind of have to write my code this way if I'm going to use it as a model. Yeah, great question. What else is on people's minds? What other questions do folks have? All right. So we've written this student model. Now let's put it into action and let's use it. What I can do is if I go all the way down here to where I have my view or my route to get all of the students. Let's comment this out for a sec. And let's use this student model. And we can do a lot of interesting things with it. For instance, if I wanted to get a count of all the students, I use the student model and it has a method named query. I can do students.query.all, and actually I apologize, that should probably be student. And actually, just to be safe, I'm going to rename my model to be students with an S to match my database table name, because that is important. And it's always the singular versus plural that gets me. That's one of the most common gotchas. So I can use this model to do an SQL query, and it has a whole bunch of built-in methods. Okay, and if we do a quick search, maybe this part of the SQL Alchemy docs will, I think, be a bit friendlier. Though even here, you can see how reading documentation is really a skill. And actually, let's change that to count. And if I look here on, they call it the query API. So this isn't an API like a server. This is an API like the interface to working with this class. An API stands for Application Programming Interface. So it gets used in a couple different contexts. So, there's methods for adding columns, deleting columns. We're going to look at getting all the data in just a second. But if we look at count over here, we see that what we can do is on an instance of a model, I can call this method count, and it's going to return a count of the rows that the query would return. And they even show us a sort of simulation or example of what the SQL would look like for some sort of table, right? So as we start working with these more powerful libraries, it becomes really important to read the doc. And reading documentation is absolutely a learned skill. As you can see, it's not an easy task. And this is also where tutorials and other things become your friend. And so the next model method we're going to use here is all. And this is going to return all of the rows in our SQL table. So let's do all students equals students.query.all. And we can close out the split here. And this would be the same as if we had done select star from students. And now we can come back to this sort of serialization function that we wrote earlier and this logic, because now we need to work with this a bit. Because now this isn't a bunch of dictionaries, it's a bunch of instances of our student model. So we have to work with it a little differently. And if I go back up here to the serializer that we wrote, we're going to go ahead and modify it. And it's going to look something like this. So this is no longer, just to add a little bit of type annotation, it's taking in instances of our student model, and we want to turn it into a dictionary. So now we would do student.firstname, and let's add the ID here just sort of as a test to make sure that this works. And over here, right, we're not grabbing a key from a dictionary anymore. We're grabbing an attribute off of an object. And same here with age. And same here with grade. And so now this serializer becomes way more important.
You have a typo with first name,
Oh, thank
missing
you.
the F.
Oh, yeah. Perfect. And now it's blue as it should be. Thank you very much. So now, fingers crossed, we're using the student model right? And this is going to talk to Postgres, and it's actually going to do a couple SQL queries. It's going to get all the students. And in fact, let's print out all the students just for fun, just to see what that looks like. And then we're going to turn these student objects into dictionaries and use JSONify and send it all back. So let's see if our Python code runs, if there's any typos. And good news, the Flask server is running. And let's do this with curl on the command line, because why not? And it would help if I hit the right API endpoint. And it looks like we hit an error here. We see a whole bunch of stuff printed out, in fact, but down here we see attribute error. Dict has no attribute ID. In fact, if I look in my Flask program that's running, we see that a whole bunch of debug and error information has been printed out. We see here the request came in to get all the students. When you see an error message, again, the important information is almost always at the very bottom. It's either the very bottom or the very top. So always start at the bottom of the error message. And indeed, we see here line 52 is where the error message is coming from. And if I go there in my code, we see that's in the serializer that I was messing around with. We see here dict object has no attribute ID. Right, so this is telling me that I did something wrong. And I do need to do a little bit of investigating here, because there should be an ID attribute on the student class. And in fact, if I do here in pSQL, select star from students, we see that ID column is there. So I wonder, did I forget to add the ID on my model? We have the ID over here, so it's on the model. So I'm not quite sure where I went wrong. So a good way to debug is, I know that the error is coming here from line 52. So let's add some print statements to see what's going on. And when I'm debugging like this, I like to just add some huge print statements, and we'll just say in student serializer, right? And let's just say student, and let's print out the student, and let's print out student.id, because that seems to be where the problem is. And then let's print out turning object to dictionary. And this way, I'll know when I'm in this method, in this function, I'll get a printout of the student object. That might be helpful. I'll get a printout of the attribute on the object that seems to be causing the problem. And if that works, I'll get this print statement that tells me we're going on to here, right? So if I don't see this, I know that the problem is here on line 53. So let's run this again. And let's use the browser this time. And we'll do localhost port 8000/API/v1/students. And let's see here. I think I just have a typo. There we go. And in fact, we see Flask when I do this in the browser, because the debug mode is on in Flask. It gives us a sort of nicely printed version of the error message as well, with the key bit here, as well as sort of the stack trace. But what I want to look for now are the print statements that I added. And so I see, as I'm reading through this, I see sending the client all the students. And if I scroll down in my code to this route, that's my first print statement here on line 78. I see the count. That's great news, right? That means that we are talking to Postgres. We got the count of all the students. And then I see this printed out here. 1 John, 2 Jane, 3 Bob. And that's coming from this print statement here on line 83, right? Because this is printing out all of the students. And when we made this student class, we added the dunder repr method. That's just the ID and the first name. If I scroll back up, We can see that here, right? ID, first name, and that's what we're seeing in this print statement, ID, first name, ID, first name. So if we keep kind of navigating through the code and just following it line by line, we know that this is printing successfully. We know that we talked to the database and we successfully got all the students, which is great. And I know that I'm able to see the student IDs. So this is really good debugging because it's confirming that a lot of things are working and helping me isolate where in the code the problem is coming from. So I now know really it's somewhere in here that's a problem. My next print statement is in student serializer. And I know that that print statement is called in this student serializer function. So if we go up there and we keep tracing the flow of execution, we know we've gotten to line 51 successfully. Right after that, I see printed out ID 1, first name John, last name Doe, and so on. And that's from this print statement on line 52. So this is great, right? The list comprehension is feeding the first student from the list into the student serializer. And then that seems to be where we run into a problem, because this was printed out, but then we get an error. So something is wrong here with my code and probably here as well. So this student.id is not correct. What I also find interesting is when I'm seeing this student information, this sure looks like a dictionary that's being printed out, but I shouldn't be seeing a dictionary. And in fact, we saw that dunder repr method happening before. So I wonder if I'm passing in the wrong thing. And indeed, I am. This is all students. This is the query I made to get all the students from the database. But my list comprehension is old. And it's going over not all students, but this student's list from way, way before that's up here. And that's why here we see printed out a dictionary instead of over here with the dunder repr method. We saw the student model, like printing out information, and we saw like instances of our student object. So this one was a little tricky, right? And my code was correct. The good news is this is a really easy error to fix. My sort of meta analysis here is you have to be really careful modifying or refactoring existing code. Just leaving this sitting here was kind of dangerous. If I had deleted it, we would get a much better error. And in fact, if I run my Python API again, and we hit refresh in the browser to send the request to my server again, to hit this endpoint again, we see a new error, right? We see name error. Students is not defined from line 77 here in our list comprehension. This is a much better error, right? Because this is much easier to understand and it's less confusing and it's clear what went wrong now, right? And rather than students, this needs to be all students. And I just want to pause and check in here to see if folks have any questions about sort of the debugging workflow that I just went through, or what the source of that error was, because I think this is a great example of a real world issue. Rick, yes, sir.
Yeah, I see that, and I'm sure we'll go over it later. I can't remember what I used, but so the get works just fine. But if you want to write to the database, do you need more data, like permissions? Because well, the reason why I ask is to be able to write to my database, I had to include the password in the code to the user, the super user,
I would
to be
have to
able.
look at, I think I'd have to look at your specific code.
Okay.
Yeah. Yeah, I'm not sure if we need to send the password to write to the database. I'd actually have to check the SQL Alchemy docs.
Now, are we
That may
going to
be the
go
case.
over modifying the database with the Python Flask?
Not right now, because when
Okay.
we get into
Alright.
Django, we'll be using it that way.
Alright.
Tom, yes, sir.
Um, it's probably because of, once again, with what we're inheriting, but unlike yesterday, we're not dropping tables or anything like that. So is that being automatically done under the hood for the model?
So that's a good point. The table was already created when I ran the SQL script earlier. If we kind of scroll up a bit, here where I ran students.sql, right? And that went ahead and created the table. Um, so in this case, we're not seeing creating a table using SQL Alchemy. We're just seeing how to use the model to interact with the table, but we can use SQL Alchemy to create a table as well. Both writing data to the database and creating a table with SQL Alchemy are really common use cases. And I think they're pretty straightforward to implement off of this. But I just want to keep us focused right now on the fundamentals of having Flask set up with SQL Alchemy and reading from the database.
Gotcha. Okay, so that's something we'll cover later. But so if we
Correct.
still need to add and drop tables, that's still going to be done at this point through an SQL file.
Right now, yes.
Okay.
Awesome. Thank you. Are there any other questions about the debugging workflow that I just went through? Okay, awesome. Let's run this code and let's see if this works. So far so good, right? The Flask app is running. Let's refresh the page again. And now indeed we see our student data coming back. We see the serializer giving the age, the full name, the grade, the ID. And in fact, we see our print statements, which are kind of a really nice way of seeing what our application is doing. And now we've got everything working. So just to recap and review the steps that we went through here. From the top, we install SQL Alchemy and PsychoPG2. We configure Flask to use SQL Alchemy. And indeed, we may need to add our password here. It depends also, I think, on the configuration of the Postgres user. But we tell Flask what database we're talking to, that we're using PsychoPG to talk to it, our Postgres username, the host where Postgres is running, and the database name. And the database does need to already be created. We then connect Postgres to SQL Alchemy here by passing in our Postgres app as an argument. And that returns this DB class that we can use for all sorts of things. We then write a student's model, and this model name has to be the same name as our table name. And we have to inherit from SQL Alchemy's model class. And instead of using dunder init to put in information, we create all these fields. Right? They're class attributes, but really we call them fields. And we use SQL Alchemy's DB class and its column method to create different columns and to tell it what type each column is and extra information. And I added this dunder repr method to print out information about an individual student just to make life easier. And once we have our model, we can do all sorts of things with it. And this is where reading the SQL Alchemy docs and the API reference for the model class is really useful. And so I can do students_query.count, that gets me all of the students. I can do that gets me a count of all the students. I can do students.query.all to get all the students from the list. And to kind of touch on some of the questions folks had, if we start looking through the API docs for, here we go, for SQL Alchemy for query, we'll see there's a whole lot of things here, like add an entity that might create a new table, for deleting things, filtering, and then just a whole bunch of options. Pretty much anything you can do with SQL, there will be a method here for. And so what we end up with is by using this model, we talk to the DB, we get our student information, and then we send it back to our client, right? Whether that client is the browser or that client is curl on the command line, or that client is a JavaScript program. So I just want to pause here and see if folks have any questions about SQL Alchemy and the material we've covered. Alex, yes, sir.
So is this I heard it's always best practice to have your back end and your front end separated. Is this getting into that? Is this breaking that up?
Yeah, that's a great question. So to use that terminology, a front end is basically another word for the client. Here, let me scroll up a bit. There we go. And backend is basically another word for the server. Now, backend's sort of like a general term, like the database is backend too, but the backend is really everything that's not the front end. So it would include the server and the database. So indeed, we now have our front end and our back end separated because we have a server that talks to a database, and we now have a way with these HTTP requests, right? By using these different URLs to have any sort of front end or any sort of client talk to our back end and get data from it. Does that help answer your question?
Yes, it does. And when someone says they're a front end developer, does that just mean they're writing a bunch of HTML, CSS, and JavaScript?
Yes, but as we'll see, the JavaScript part of front end can get extremely complicated. For instance, let's look at Google Maps. What I'm looking at right now is a ton of JavaScript that's actually running in my browser. And this is the front end. So like all of this animation, all of the code that makes this scroll, that makes when I click on this, a menu pop up and go away, it's using some HTML and CSS, but also a ton of JavaScript. All of the data, this name, capital grill, the latitude and longitude of where everything is on the map, lives somewhere in the cloud in a database behind a server. And so we have an extremely complex JavaScript application here talking to a server over the cloud. So there's a whole lot more to front end dev, or to go to an example we were looking at the other day, the Amazon.com website. Like as I type in here, it's making a request to the server every single time I type a letter, and it's updating this. So there's some HTML and CSS, and again, a whole lot of JavaScript. And in fact, there's whole frameworks around this. So the front end engineering part has a lot of complexities of its own, which we'll learn about as we get later into the course with React.js.
Thank you for the clarification.
Yeah, great question. Great question. What we've seen with HTML and CSS thus far is really only scratching the surface. And the big thing in sort of front end dev has been the shift from, several decades ago where websites were not very interactive. They were called static. Even something like hovering over something and having this pop up, like in 1990, that feature did not exist. And this is actually powered by JavaScript running on the front end that does this. And so originally HTML and CSS was basically like for academics to share documents and information, what we call static documents. And the web and JavaScript just got so useful that it kind of, metastasized and snowballed. And now we have like full on programs and applications and and things like that running in the browser. Like I'm sure, here we go. Let's see if I can play the snake game and have it not die. There we go. So this is JavaScript code. It's running in my browser, so I can really have anything I want happening in here. And that's really the big change in the web, and the big change in the front end was this is not a static document, right? This is a full-on application. Yeah, great question. All right, folks, thank you very much. We covered a lot of ground here, right? We saw how to set up SQL Alchemy and PsychoDB. We saw how we now have the genesis of a full stack application. Our next lesson will focus more on the front end of the client and having it talk to the back end and doing more work. But we saw a bit of a preview of that today with this JavaScript code, right? And the next step is to get this JavaScript running in the browser. So we've learned about what a web server is, what a web server does, how to set one up with Flask, and then how to connect it to a database. All right, folks, happy coding and thank you very much. And let me go ahead and stop our recording.